We're going to clean it now with some 1 molar hydrochloric acid. So same process again. Just going to bung in the bottom. And take my hydrochloric acid. Make sure you're wearing your gloves and your glasses. Chamber. The acid. Take a note of the time, and again we're just going to let that sit there for approximately 15 minutes. Okay, the acid has now been cleaning for just over 15 minutes, so it's time now to remove that. And again, same process, we're going to remove it, we're going to sweat it with deionized water. I'm also going to tab it dry with some of the blue tissue, and then we're going to use the alcohol at the very end just to get the lens perfectly clean and dry, ready for deployment. So using the telemetry that we've got this sensor connected to, we were able to see that the sensor needed cleaning when the results started to spike and show some abnormal results. As you can see, this is a process that we can do on site. We are on site here. We have the cleaning kit, which we can provide if required. It does take a little bit of time, as you can see. We need to allow each of the cleaning agents that we're using a little bit of time to work and clean the inside of the unit. But it's a fairly straightforward process. It's something, as you can see, we can do on site. Again, recommendations of how often we need to do that really depends a little bit on the results that you're seeing in the telemetry. So if things seem to start spiking, or the readings look like they're abnormal, it's likely that the sensor may need cleaning. The pump itself will elongate that process, but at some point you are going to need to come to the field and clean the sensor. This is something, as I've demonstrated, you can either do yourself, or if you would like us to do that, we're also more than happy to come to site and clean the sensor. Okay, to give you an explanation of what we're measuring here and how we're doing it. So within the river here, so the flow is coming here from left to right. We have a depth and conductivity sensor just behind the steering wheel on the gauge board, and that's cabled through to the data hub, which is mounted on the post here. The data hub is powered by solar. Now, because as you can see, we're under trees, we're actually pointing in the wrong direction. What we've done is we've run a cable which we've dug into the ground from here, and it goes approximately 40 meters to your right if you pan all the way through. The CTD sensor that we've got in the water, and also the nitrate sensor that we are currently cleaning with a cleaning pump which is firing currently every 14 minutes. What am I holding here? So the nitrate sensor is currently out of the ground because we are cleaning the lens ready for redeployment. So one of the challenges that we have here with the water is the sediment that we've got with the fluctuation of the water. What we want to do is try and keep the water as clean as possible for the sensor to read. So what we've actually got here is effectively a horizontal stilling well. So the nitrate sensor will be inserted in this bottom tube. The top tube will keep it afloat, and effectively it will float with the water. So it's always approximately 20-25 centimeters below the surface. The sensor is, that is, it will float up and down with the water horizontally, and what that is doing is it's ensuring that we're not picking up any sediment in the cleaning pump and then cycling that through the measuring lens, therefore distorting the readings.